Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
We're going to investigate solving equations. Now, before we even get started into this, there is one way that we can do this digitally that takes out all algebra. So anytime you get asked to find all solutions, roots, zeros, or solve, it really means the same thing, okay? It really does. And one way that you can do this by technology is you can find all real roots, emphasis on the word real, by making it equaling 0, graph it with technology, and see where it crosses the x-axis. And again, that will find you the answers, but if you're in a class that requires you to demonstrate knowledge of your algebra skills, then this method is just a great way to check your work. So again, it's great to be able to know how to check your work that way, but you must be able to show your work should your professor need you to see that. If you're one of my students, I have to be able to see that at the dual credit level because that's what I'm grading you on. So let's say you have a linear equation. 7x minus 4 equals 3x plus 8. Okay, it's linear because the highest exponent is 1. So again, if you're using that technique, we would just have 7x minus 4. We'd have to move over the 3x by subtracting, and we'd have to move the 8 over by also subtracting. So now everything is on the left-hand side. There would be nothing left on the right. And if I were to graph it, I can absolutely see that it crosses the x-axis at 3. So my answer is probably 3. So now that I know the answer, I would need the work to be able to justify it if that's what I was getting graded on. So one of the things that we do is the addition property of equality. So we could add 4 to both sides. So if I added 4 to both sides, that would give me this statement. Now I can do the subtraction property of equality to subtract 3x from both sides. So if I subtract 3x from both sides, and then I could use the division property of equality to divide both sides by 4, and I get x equals 3. I can always check my answer by substituting it back into the original, or I went ahead and graphed it before I even did the problem, so I knew what the answer was going to be. So technology gave me the answer of 3, my algebra gave me the answer of 3, they are agreeing, I'm good to go. Now, because the exponent was 1, the highest exponent, we only got one answer. I'm sure by this time in your math career, you've also seen quadratics. So x squared plus 5x equals 24. Okay, so again, we can come in here. X squared plus 5x. I'm going to bring that 24 over with the 5x, so minus 24. And graph that. And it's giving me two answers, this time one at 3 and one at negative 8. So I'm seeing two answers of 3 and negative 8. So technology has told me the answer. And if I'm taking an ACT, then great. That's pretty golden because that's a quick way to do it. Anytime you have a quadratic, we have multiple ways of solving. My favorite two are factoring and the quad formula, and I'm going to factor anytime I can. And since I've recently in a video gone over factoring, I'm going to use factoring and not the formula. Depending on which university you're at taking college algebra, you may or may not get a formula sheet. So that's one reason why factoring is a great way to save it. So what multiplies to negative 24 and adds to 5, we get positive 8 and negative 3. And this is written as a product. Well, the only way to multiply to 0 is to multiply by 0. So either x plus 8 has to equal 0, or x minus 3 has to equal 0. This is known as the zero product property. So subtract 8 from both sides, add 3 to both sides. And now we're getting those exact same two answers that were shown in the graphing calculator, or I could substitute it back into the original. 3 squared plus 5 times 3. Well, 9 plus 15 is indeed 24. Negative 8 squared plus 5 times negative 8. That would be 64 plus negative 40. That is also indeed 24. We can always check it algebraically like that. But again, we can also solve it by looking at the graphing calculator. Now, one of the reasons why we don't just want to rely on technology is in this case right here. There's no middle term, right? It's just the quadratic term and the linear term. So x squared minus 5. I've moved everything to one side. Pop that into the graph. It's crossing the x-axis, but it's crossing at decimals. And if you were to try to factor this, it would not factor, but it definitely has x-intercepts. And in a lot of university level classes, they expect exact answers, not rounded. So if you went ahead and calculated the 0, left bound, if you don't know how to do this, you can always watch a YouTube video. It's at a decimal, 2.236. And we can see that that this is very symmetric, so the other one is negative, right? Well, to get rid of a square, can I just square root both sides? So that would leave me with the square root of x squared equals the square root of 5. And we know that these cancel out. What is the square root of 5? Okay, 5 is a prime number, so my radical doesn't reduce. Oh, it's that decimal, 2.236. The thing is when you square root both sides, don't forget the plus or minus. So we really should say x equals plus or minus the square root of 5. So anytime you're undoing an even power, because 3 squared is equal to negative 3 squared is equal to 9. If I said x squared equals 9, you would have to tell me that x is positive 3 or negative 3. Okay? Positive or negative 3. Hence, instead of writing it twice like that, we just write plus or minus. So that's where that's coming from. So, what if I had this? Okay. Notice how I'm not doing any algebra except moving that one thing over. Again, decimal answers. Okay? And I'm not a big fan of the quadratic formula if I can avoid it. So in this case, I can work backwards. I can square root both sides. I can write x minus 4 equals plus or minus the square root of 5. And then I can add 4 to the other side and get 4 plus or minus square root of 5. Okay, so now let me check with my calculator. So I'm going to calculate a value. 4 plus the square root of 5. So see how I just typed it into the x equals line on my graph? Worked out perfectly. What about 4 minus the square root of 5? That also worked out perfectly on my graph. My calculator took care of substituting, and I can definitely see that those are the x-intercepts. So what if you wanted to do the quadratic formula? Okay. Well, in order to do the quadratic formula, it has to equal 0, and right now it equals 5. So we'd have to FOIL it out. Then we'd have to move the 5 over. And then if you've learned the quadratic formula before, you know it's x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay. Okay, so our A value is 1, our B value is -8, our C value is 11. And that comes from the quadratic, the linear, and the constant term. So since B is -8, negative B is going to be +8. B squared, so put -8 with the squared on the outside of the parentheses so you don't make a sign error, minus 4AC all over 2A. So we get 8 plus or minus. Okay, and then we'd have 64 minus 44, which is 20 for a discriminant. But 20 is not a reduced radical, so you have to reduce that down. Remember, 20 is 2 squared times 5. Which means that the square and the, like if you look at this, the 2 can come out, but the 5 has to stay in. You can go back and watch a reducing radicals video. And now I have 8 plus or minus 2 squares of 5 divided by 2. And whenever I divide it by 2, I get 4, because 8 divided by 2 is 4. And 2 squares of 5 divided by 2 is 1 squared of 5. Same answer. But look how much more work that was. So if they were always written like this, if something squared equals a constant, it's great to use that square root property. Or when the b value is 0 or missing. Like I could have written this x squared minus 5 equals 0. It skips over that linear term. So when they're written in one of those two formats, we can skip that long drawn out quadratic formula. So what if they're written like it looks like we should do the quadratic formula, but we don't feel like doing that quad formula? This is when a process called completing the square is going to come in. Okay, now I will tell you that completing the square is something that my dual credit students have to know because they have to also be able to do circles. So if you're going to need to do circles in your class, you're probably going to need to know this process. So the first thing I'm going to do to solve by completing the square is I'm going to move my constant term to the other side. Okay, now we all know that a square has equal length and width. Everything's equal. So I'm going to put the x squared in the first term. And by the way, if your first lead coefficient is not 1x squared, you have to divide everything by that number to do this as 1x squared, even if it causes you to have to deal with fractions. Now I have to split the 8x up evenly because it has to be a square. So I'm going to write minus 4x and minus 4x. Now I can see that these have a GCF of x, and I can see that these have a GCF and x times minus 4 and x times minus 4. I can see that this is going to be an x minus 4 by x minus 4, but that's going to cause an added number to wind up in the box. Because this would result in a 16 being here, I have to add 16 to both sides. Okay. Now that I've done that, my left side will factor to x minus 4 squared. And my right side will simplify to 3. Now I can avoid the quad formula because I've written this as something squared equals a constant. So x minus 4 equals plus or minus the square root of 3. Add the 4 to the other side. 4 plus or minus the square root of 3. And of course I'm going to check it with my graphing calculator. Again, I'm going to put in the original. That way I don't have any of my own mistakes in there. It's equaling 0 right now. I'm going to graph it. And I'm going to calculate a value. 4 plus the square root of 3. Absolutely, across there. What about 4 minus? Oops. Most definitely. We got there. So again, this is great because it allows us to skip doing that long drawn out formula of the quadratic formula. Okay. So again, if you take the 8 and you divide it by 2, you get that number right there. And if you take that number and you square it, you get what we added to both sides. It's kind of a hint for what's going to be coming. Okay. Now, I am going to do to this different than most textbooks with the way that I'm doing it, because a lot of textbooks don't do it exactly like I'm going to write it down. And I will go back and I will show you how they write it down instead. Okay. So the first thing I'm going to do is I'm going to move the constant to the other side. Then I want my lead coefficient to be 1. So see how I divided everything by 3? A lot of textbooks instead are just going to write this. And they're going to factor it instead. And I'll explain how that makes a difference in just a second. And then you can choose which way you like better. Okay. So divide by 2, square. If I add it to the right, I have to add it to the left. Now this is 4 over 1, which is the same as 12 over 3. So when I add it together, I get 7 over 3. Or you could have grabbed a calculator and added those fractions. What a lot of books will say will be, if you're going to put plus 4 in here, 3 times 4 is 12. You have to put plus 12 over here to keep both sides the same. Because if you had distributed it, you would have added 12 to the left, so you have to add 12 to the right. Well, now if we just take what they have there and divide by 3, we still get 7/3. So that's why I don't like doing it that way. I like kind of doing it all in one step, or a little bit different, so that I don't have to worry about distributing. Some books have you add 0 to one side. So they say 3x squared minus 4x equals -5. And they have you add 0. Instead of adding to both sides, they have you adding 0. So if you put plus 4 here, 3 times 4 is 12, you have to subtract 12. That way you've added 0. But aren't you then just going to add the 12 over and get 7? Yes. So different textbooks are going to write it different ways, but they're all getting to the same thing. They're all keeping the equation balanced. Okay, so their next step is to do the square root of both sides. Now a quick reminder is that our denominators always have to have a perfect square root, and right now 7/3 does not have a denominator that's going to have a perfect square root. So I'm going to change this to 21/9. Times 3 and times 3, right? So now when I reduce this, I get x minus 2 equals plus or minus square root of 21 over the common denominator of 3. And then I'm going to add 2 to the other side. If you want to give it all a common denominator, you could write 6 plus or minus the square root of 21 all over 3, but you don't have to. So if you ever look for the proof of the quadratic formula, the proof of the quadratic formula literally is taking ax squared plus bx plus c. Moving the constant over, dividing everything by a. X plus the middle thing divided by 2 squared, which means they would have to add b squared over 4a squared to both sides, which then means we need a common denominator, so this would be negative 4ac over 4a squared plus b squared over 4a squared. So we'd have b squared minus 4ac all over the common denominator, 4a squared. Then we need to square root both sides. X plus b divided by 2a equals plus or minus b squared minus 4ac. The square root of 4a squared is 2a. Move that over. And now they have a common denominator, so we have negative b plus or minus. So to get you this formula, they just did the completing the square process on all variables so that you can get the formula, so that you don't have to do completing the square, especially when the a value is not 1. Something quick to note, if the discriminant, that's that b squared minus 4ac part, is greater than 0, you will have 2 real x-intercepts. They might be rational or irrational. Okay. If it equals 0, you will have 1 real rational root. In other words, what's going to happen is if the discriminant is 0 and you're looking at your graph, here's the x-axis. I don't know whether it'll be on the positive side or the negative side, but that parabola is going to come down and bounce off the x-axis and come back up. And so you're just getting this one answer right there, versus had it been greater than 0, when it's greater than 0, we're getting these two right here. What about if it's less than 0? If it's less than 0, you're getting no real root. And that would be because your x-axis is here and it's just never going to cross it. So you can actually just look at the b squared minus 4ac and tell how many roots there are going to be. Okay. Now, I do use the word real because we do have something called imaginary, and therefore, yes, imaginary roots can happen, and I'll be doing a video on that soon as well. So let's just practice that quadratic formula just one more time. 3x squared minus 1 minus 5x. So if you'll notice here, they did not write it in descending order. That doesn't mean we have to rewrite it one time to be able to get our answers. We can see that a is going to be 3 because that's in front of our x squared part. B is going to be negative 5 because that would be the next term if we were writing them in descending exponent order. And our c value is negative 1 because it's the constant. So I always sang to my algebra students, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we've substituted it into our formula. Notice there are no letters inside that equation there. Okay. So we get 5 plus or minus the square root of 37 divided by 6. Note that b because 37 is greater than 0. This will cross the x-axis 2 times. Okay, 1 at 5 plus this root 37 over 6, and 1 at 5 minus root 37 over 6. I like leaving them in this format because they're exact answers and I don't have any rounding. Anytime your discriminant reduces, though, you have to reduce your discriminant. You cannot leave these fractions unreduced. Also, if the denominator is ever negative, let's say you had 8 plus or minus 2 root 5 over negative 3. I would rather use multiply both numerator and denominator by -1 and make it -8, still plus or minus, because when you multiply a positive negative times a -1, it's still minus or positive. Isn't that the same as plus or minus? All over positive 3. So I like keeping that denominator positive, and that's how you're going to see the answer most of the time. Okay. So what happens if we have equations that have rationals in them? So 3 over x minus 2 over x minus 3 equals -12 over x squared minus 9. Okay, the first thing I'm going to do is I'm going to check to see if it even has any answer. So I'm going to use the same strategy. 3 over x minus, notice I'm using my vertical fractions, and I'll add the 12 over x squared. Whoops, wrong button. I did it again. And I'm going to graph it. Oh, that's really hard to see. I'm not sure that it ever gets there. Maybe it does. Let's see, calculate a 0. I can see that my y's are negative here, where they were positives. So somewhere in here it had to have crossed the x-axis. Ah, it's saying at -9. Or I can come in here to the table, and these are positives, and these just keep going more positive. Do they ever go negative? I'm not seeing it. So maybe just that -9. Okay. It looked questionable, but we'll go ahead and figure it out. So we have to clear fractions. So we're going to multiply everything by something to clear fractions, similar to how I cleared out fractions in our complex fraction examples in the previous video. So first thing I'm going to do, as always, is factor, 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 factor. Okay, and we know x cannot be 3 or -3 or 0, because those would make domain errors, which is why there was undefined in that chart when I was glancing through. So if I were to multiply everything by x, I'm distributing it through, this x would get rid of x, but I still have denominators. So I'm also going to multiply everything by x minus 3. And this gets rid of this, and this gets rid of this, but I still have a denominator. So I'm also going to multiply by x plus 3. And the x plus 3 gets rid of x plus 3. So I basically multiplied by what would have been the least common denominator. Now I'm going to write what's left out. 3, x minus 3, x plus 3 minus 2x, x plus 3 equals negative 12x. I need to simplify that. So first I'm going to multiply these two together, but they're that conjugate pattern. So I know it's going to make x squared minus 9. Then I'm going to multiply that by 3, and I'm going to get 3x squared minus 27. I'm going to distribute my negative 2x, so negative 2x squared minus 6x equals negative 12x. It's quadratic, so I need it to equal 0. So I'll have my x squared, and that's because of the 3 minus the 2. If I add the 12x to both sides, that'll make positive 6x minus 27. Now it equals 0. And I can factor this. X plus 9, x minus 3 equals 0. So x equals negative 9, which is what the calculator said was the answer, or positive 3. Now the calculator didn't say that one. And the reason because of that is, let's write this here. X cannot equal 3. So x being 3 is an extraneous root. So my only solution is negative 9. Okay. So anytime you have rational equations, make sure that you go ahead and you clear your fractions and then handle it just the same. So just multiply by what would have been the least common denominator and you're good to go. Now what happens if you have an absolute value equation? Okay, now the good news is that there is an absolute value way that you can check this. If instead of doing the green button y equals, you do the green button window. Let's see if I can get that refocus. There we go. Our number 1 menu is absolute value, and we have x plus 5. And I'll subtract the 9 over, so it makes it equal 0. And when we graph it, we're seeing for sure an answer at 4 and then an answer clear out here. So we'll go ahead and find out what that is. You can, so I need to go, when did my window become this? Normally I have it negative 10 to 10. Let's see. That didn't help any. So I'm going to change my window to go left 20. Ah, okay. So, yeah. Now I'm definitely seeing it. That looks like negative 14. Let me double check. Yep, it is. And the other one looks to be at 4. So I am seeing my 2 answers. But the proper way to do this is absolute values are either a positive number or a negative number, right? Positive or negative 5 has an absolute value of 5. Because 5 is 5 spaces from 0 and negative 5 is also 5 spaces from 0. So we have to think plus or minus x plus 5 equals 9. See how I dropped my absolute value signs by going, okay, it could have been positive or negative. So if it's positive, then we would have x plus 5 equals 9, subtract 5. Or negative, we'll distribute that. So I'd add 5 and divide by negative 1. And now we're seeing proof of those 2 answers. And if you think about it on a number line, if negative 5 is in the middle, because that zeroes out my parenthesis, what is 9 spaces each way? 9 spaces up is 4, 9 spaces down is negative 14. So the distance between x and negative 5 is 9 spaces. That's really what that says. However, we might get a little more complicated. It might be something like that. Okay. So again, absolute value of 2x plus 5. And I'll subtract the 3x. And I'll add the 2. That way everything's on one side. And I'll graph it. Ooh, now I got to change my window the other way, it looks like. We'll go from negative 10 to 20. Well, absolute values are supposed to make V's, so let's go negative 50 to 50. And I'm going to number by tens because I don't want to see all those little bitty tick marks. All right, so right now it's just looking like the one answer. Okay, so is that at 7? It is. Okay, so let's see what's going on here. Again, absolute values, what's inside? Could have been positive or negative. So we have to do it as once the positive equaling 3x minus 2 or the negative equaling 3x minus 2. And that's how you drop the absolute values and get rid of them, is you have to do it once as a positive and once as a negative. So you have to make two separate equations. Okay, so this would be 2x plus 5 equals 3x minus 2. So I'll add 2 and get 7. I'll subtract the 2x. Hey, x equals 7. Our calculator supported that. So what's going on with this other one? Negative 2x minus 5 equals 3x minus 2. Add the 2x, add the 2. Negative 3/5. Well, let's check that, because I'm getting two answers. It's not 0. Okay, why did I get that from my work, but I'm not getting it from the graph? Well, let's check out what happens when I substitute negative 3/5 in. The absolute value of 2 times negative 3/5 plus 5, we'll look at that, versus 3 times negative 3/5 plus 5. We're just going to check those out, and to save you some trouble, we'll just go ahead and 2 times negative 3/5. I'm using parentheses instead of the fraction button, which is okay. That's 3.8. Okay. That's oh. If the absolute value wasn't on there, I bet they would be equal. Let's check. No? So see here how one's a positive and one's a negative? They have the same number, but the absolute value is kind of throwing a wrench in our gears. So numerically they're equal, but with the sign error that was distributing the negative. It turned out this time we had an extraneous solution. So our only answer is x equals 7. So please keep in mind that extraneous answers can happen. Okay, now I did just say solving equations. I didn't say what kind. So this is kind of a just blanket, let's solve everything. So what if they have a radical? Well, anytime they have a radical in them and you're solving them, first of all, you must note that the domain of this has a restriction that 2 minus x has to be greater than or equal to 0. So negative x has to be greater than or equal to 2. So x has to be less than or equal to negative 2. Because when I divide by a negative, I have to flip that inequality. So I better be getting a negative answer. Could I graph it and check? Absolutely, I could. This should have been a negative 2, so this should have been a positive 2. That's making too many sign errors in my own head. All right, so to get rid of the radical, the first thing I'm going to do is I'm going to isolate it. 2x minus 1 equals negative radical 2 minus x. Then, to cancel out, I'm going to square both sides. Notice how the entire monomial there gets squared. That's a monomial. So a negative squared is a positive. The square and the square root cancel out, and we're left with 2 minus x. Here we have to FOIL. So 4x squared minus 4x plus 1. It's quadratic, so I'm going to set it equal to 0. 4x squared minus 3x minus 1 equals 0. This one happens to factor. 4x plus 1, x minus 1. And you can double check that if you want, but negative 4x plus 1x is negative 3x. And then that zero product property says set each of them equal to 0. So x equals negative 1/4 or positive 1. Well, they both seem to fit in the domain, so let's just go ahead and check. 2x minus 1 plus that square root. Okay. Calculate the value. It's going to graph it. Okay, negative 1/4. That works. 1. Nope. And the reason for that is one side is probably a positive number and the other side is a negative. Let's double check. If I substitute 1, 2 times 1 is 2. But if I substitute 1 into here, I get 1 minus the square root of 1, which is 0. And 2 does not equal 0. So 1 does not work when you substitute it back into the original. So 1 is extraneous. The only answer is negative 1/4. So make sure you're verifying your answers as you go. Okay, and what if we get into something like this? Unfortunately, there is only one way to solve this because it has 4 irrational answers. So we have to use what's kind of a trick for this, okay? I'm going to rewrite this problem as x squared. I'm writing that in pink on purpose. Okay, so instead of everywhere I have pink being x squared, right? I'm going to change that. So I have the pink part squared minus 8 times the pink part plus 8 equaling 0. These are irrational answers, so I'm either going to have to solve it by completing this square, or I'm going to use the quad formula. In this case, I'm going to use the quad formula. So p equals, not x equals, because these are p's, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So 64 minus 32 is 32. Okay, 32 is 2 to the 5th. Or 2 squared times 2 squared times 2, if you want to think about it. There's 5 2's there. So p is going to equal 8 plus or minus 2 times square root of 2, which is 8 plus or minus 4 root 2. And when we divide that by 2, we get 4 plus or minus 2 square roots of 2, 4p. But I wasn't supposed to be solving for p. I was supposed to be solving for x. Remember when I said p equals x squared? So 4 plus or minus 2 square roots of 2 equal x squared. And how do I get rid of a square? X equals plus or minus the square root of 4 plus or minus 2 square roots of 2. I'm going to get 4 answers here, okay? Because it's x to the 4th. I'm going to have 4 plus 2 square roots of 2, 4 minus 2 square roots of 2, negative 4 plus 2 square roots of 2, negative 4 minus 2 square roots of 2. Now let's double check all 4 of those answers. So our original problem was x to the 4th minus 8x squared plus 8. We'll graph that. Oh, definitely. Oh, look at that nice pretty W. Okay, so we had the square root of 4 plus 2 square roots of 2. It is rounding. It does say 1 times 10 to the negative 12. That's 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros, and then a 1. So there is some rounding error here. Are you okay with it being microscopically off? Okay, what about 4 minus 2 square roots of 2? Hey, that one worked out perfectly. So it didn't even have the rounding error. What about negative square root of 4 minus 2 square roots of 2? That one worked out perfectly too. And now negative square root of 4 minus 2 square roots of 2. Oh wait, no, I did minus. I need to do plus, don't I? And that one went back to that microscopic rounding error. Those are all 4 correct. The calculator just, it had to round this x value, which resulted in this being rounded. So again, occasionally we can do a substitution so that we can quad formula and then quad formula again. So we get a little creative sometimes, but your textbook is never going to give you anything that you cannot handle with the skills that it has covered up to that point, so you should be a rock star.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.